Welcome to the course on testing techniques. The agenda for this course is psychology of testing, principles of testing, static testing, test case design techniques, levels of testing, non-functional testing, agile testing, and web and mobile testing. Let us move into the first topic, psychology of testing. To gain an understanding of the psychology of testing, let us consider some of the commonly used definitions of testing. Many people refer to testing as a verification activity, a kind of proof that the program or system is working as expected and that it is ready to be sent to the user. However, this kind of activity does not add any value to the program. Adding value would mean that the quality of the program has improved through testing, and this is possible only if errors are found and fixed rather than if errors are not found. Secondly, proving that the system has no errors is a daunting, if not impossible task, and humans are psychologically inclined to give up or not try as hard if the target is not achievable. That would make the testing activity a cosmetic exercise without adding value to the program. For example, how would you react if you had to run a 100-meter race against Usain Bolt? Probably you wouldn't even try. However, if you had to run against your co-workers, you would give it your best shot, isn't it? Testing is much the same. It would be much easier if the aim of testing was to actually find errors. A tester could hope to find at least a handful of errors and get closer to the target. Setting a target which is challenging but achievable will encourage the tester to test better. Another problem with proving that the system is doing what it is expected to do is that this still does not guarantee that the system does not do what it is not supposed to do. For example, consider a billing program that gives a discount to the customer if the bill exceeds $100. The program would be perfectly correct in giving a discount to anyone billing more than $100. That is, it would be doing what it is expected to do. But would it be right in giving a discount to someone who bills less than $100? No, it would be doing something which it is not supposed to do. Thus, testing cannot be limited to verifying that the program performs as expected. Now, let us look at the correct definition of testing. Testing is the process of executing a program with the explicit intent of finding errors. This is more than just a change in semantics compared to the previous definitions. The first major distinction is that of the goal. Since humans are psychologically tuned to be goal-oriented, setting a goal to find errors encourages the tester to strive to achieve that goal. On the other hand, setting a goal that the program has no errors encourages the tester to show that it works properly by subconsciously choosing test cases and test data that will make it work. Another implication of this definition is that testing is a destructive process, which is why most people find it difficult. By nature, most people tend to be constructive rather than destructive, and hence there is an implicit bias in the human mind to show that the program works. In order to find errors, the mind has to be consciously programmed to be destructive. A natural corollary of this definition would be the question of when is a test considered successful. According to this definition, it follows that a test would be considered successful if it is able to discover an error which has not yet been discovered. This is contrary to what some people call a successful test run, a test cycle that goes through without any errors. Such a test run would be considered a failure as per this definition, as it has not added any value to the program. This can be compared to a blood test being considered successful only when it is able to diagnose the patient's illness. We now move to the next topic, principles of testing. The first principle is that the test case should clearly have two components: the inputs to the program and the expected outputs from the program. While this might seem like the most obvious thing to do, unfortunately, this is not always practiced. Quite often, testing proceeds along ad hoc lines with undocumented test cases, or even if documented, only the test cases are documented without the expected results. The problem with this approach is that when you do not know what you're looking for, any result, or even a partially correct result, might seem acceptable. Consider, for example, an accounting program, which is expected to round off results to 2 decimal places. If the expected output showing the result in 2 decimal places is not documented before testing begins, the tester might get carried away by seeing the correct value, even if it has only 1 decimal place. This has partly to do with the human psychology discussed in earlier sections, where humans are intuitively inclined to make things work rather than break things.